So today what we're going to do is we are going to correct the 8 questions from trigonometry sine and cosine rules. We're going to look at some applications of sine and cosine rules, specifically a topic called bearings. Now, bearings is a topic about ships on the sea, and it's a topic that a question every single year, a question will come on bearings. Right? It will be a question in the section 2 of your paper 2 where bearings and circle theory are in the same question. Yeah, a lot of people just try to avoid that question, but to me, I love circle theory. Right? We're also going to take a look back at some of the circle theory questions that we didn't answer. Remember, it had a couple of them involving the tangent that we didn't finish, so we're gonna see if we can look at those today. Right? So we have a lot of things to do today. So let me get started. Yeah. So let's see how we could do this. And did anybody try to do these questions? Anybody could give me an idea of what to do here? Should I use the sine rule or the cosine rule? Right? I have to find AC. AC is this side over here. It was correct with the sine rule. Right? I'm looking at the cosine rule here, right? And I want to find B, but I don't have this side A. Yeah, so that side A, I don't have it. This is the side B that I want to find. Right? I don't have the side A. I have the angle B here, yes, but I don't have the side A. And there is nothing I could do to find the side A. So I can't use the cosine rule. But Scotia are going back to the sine rule, and I can use the sine rule. Why, Scotia? Why can I use the sine rule, Scotia?
You can work out angle C.
Yes, is equal to B over sine B is equal to C over sine C. At the end of the day, I want to find B. Right? I have this, and I could find this. I can't find the side A. The only thing I know how to find with a side is Pythagoras theorem, and it's not a right angle triangle. So I can't find the side A just yet. Maybe if I had the side B yet. But I could find the angle C. Where's the angle C?
40 degrees.
40 degrees. Right? Because angle inside a triangle is 180, right? So 180 minus 118 plus 22 is 40. So Soraya and Caitlin, you all understand how I got 40 here?
Yeah.
Alright. So at the end of the day, now we can see that since we could find the angle C and we have the side C, well look, we have everything that we need and we could use this. Right? So now B, which is what we want to find, over the sine of B, which is 22, sine 22, is equal to C, which is 24, all over the sine of C, which is 40. Yeah? All I need to do is throw this 22 across. So B is equal to 24 all over the sine of 40 multiplied by the sine of 22. Right? And what does this work out to be, Scotia? Is 13.9 approximately 14. Let me call it 14. Right? So the side B is 14, and now we could actually use the sine rule and find the side A if we want.
Yes, sir.
Alright, lovely. So let's try number 2. And it's the same thing. You see what was the first thing I did here? The first thing that I did was I labeled my sides and thing correctly. I make sure I know who is the angle B. I make sure I know who is the side B. I make sure I know what I need to find, right? So let's try the same thing with this one here, number 2. Should I use the sine rule or the cosine rule for this?
Sine rule.
Right. Now again, remember cosine rule is best used if you had the two sides and the included angle. And you could see here that I didn't really have this side, if I had this side, and the included angle, well then I could have used my cosine rule, right? In this case, I still don't have two sides and the included angle. So that is a good giveaway. If you have two sides and the included angle, cosine rule is a good giveaway, right? But let's just see, this is B, so this will be the side B. This is angle C, so this is angle C. And so this is side C, and this is the side A. And I want to find AB, which is this, which is the side C. Okay? And this angle here, what does this angle work out to be? This is 83, thank you. So this here is 83 degrees. So let's just see, let's just quote the sine rule and see if we could use it. A over sine A is equal to B over sine B, which is equal to C over sine of C. What do we want to find? We want to find the side C. So we want to find this. We have the angle C, so yes, we have that, right? And we don't have the side A, so I can't equate the A with the C, right? So I can't equate those. But I do have the side B and I have the angle B. So yes, B and B. So I have these things here. So now I could say that B, which is 7, all over the sine of B, which is 44, right? 7 and 44 is equal to C, which is what we want to find, all over the sine of C, which is 53. We could take this 53 and fling it across. So therefore C is 7 over the sine of 44, all being multiplied by the sine of 53. So what does C work out to be? Yep, around 8.1. Try it and see, should I use the sine rule or the cosine rule here? This angle is 63, this angle is 101, and this is 9. So which one should I use? Sine or cosine? Remember our dead giveaway for the cosine rule. We have a dead giveaway.
Sine rule.
Right. Remember the cosine rule. If you saw that you have an angle and you have the two sides on either side of that angle, well then you could think about the cosine rule. But we don't have that. So we could start thinking maybe it could be the sine rule, right? So let's just make sure. Right? This here is the angle C. So opposite the angle C, I'll have the side C. Right? This here is the angle B, so opposite the angle B, I'll have the side B. And this here is the angle A, so opposite the angle A, I have the side A, which is 9. Right? Soraya, can we find what the angle A is? Don't worry, I'll be moving to Cape.
16 degrees.
16 degrees, right? So yes, we have all of the angles and we definitely have a side. So we could use the sine rule. We have to find AB. So we have to find this side. We have to find the side C. So let's just see the sine rule. A over sine A is equal to B over sine B, which is equal to C over sine C. Let's see what we have and what we want, right?
Excuse me.
Yeah.
Is that 116 degrees?
No, that's 16 degrees. That is the arch thing. Maybe I'll erase that. Right, 16 degrees. And you can see it looks like 16. It definitely doesn't look like 116, right? So so once we labeled everything, we're just gonna try it and see if we could use it. I still don't know if this is the one, right? So what do we need? We need to find AB, which is the side C. So the side C is what we need. Do we have the angle C? Yes, the angle C is 63. So we have the angle C, right? We don't have the side B, no. So we can't use this. But we do have the side A and we do have the angle A, yes. So we could say here now that A sine A is equal to C sine C, yeah? So these two here is what we are going to equate. So therefore A is 9, and the sine of A is, this is the angle here, A here, so that is sine of 16, and that is equal to C, which is what we want to find, that's this side here, all over the sine of C, which is the sine 63. Okay. So therefore we could just throw sine 63 across. C is equal to 9 over the sine of 16, all multiplied by the sine of 63. And calculator lady, what does this give us?
29.
Yes, 29.1. Good job. So 29.1 is the answer here for this length of this side. We wanted to find BC. BC is this, which is the side A. So we equated A and B. We had this, we could have found the angle B. So we equated A and B here, and we were able to get this, right? But now, we saw here that we had a question with the cosine rule. And the cosine rule is a little bit easy to spot. We had to find the angle C. And cosine rule is a bit easy to spot because we have two sides and the angle between them. So once you're seeing that, then you might want to think cosine rule. Right? And of course we wanted to find this angle here. Yeah, we have the three sides. And we wanted to find the angle there, right? And we have two sides and the included angle, right? So we wanted to find the angle C, so we used the cosine rule that had the angle C in it, cos C. So that means that it would be this one, C squared is equal to the other two sides, cos C. And we have C squared, we have this side, we have the sides A and B. So we have all three sides, we just want to find the angle. So we plugged in the values for all three sides, we worked it out, right? We did the arithmetic here. Shazay made this mistake and minus this number from this number, but this number was being multiplied by the cos of C, so you can't make that minus. We had to instead take this and throw it across, right? So now we got the cos of C being all of that, right? And I hope that you guys remembered doing this question last week, and we were able to make C cos C the subject of the formula to get that, and then we were able to find C, which is the cos inverse of that, right? So yes, it does look like a whole bunch of complicated stuff, but if you take it one step at a time, plug in your values, right? Work out what your values are, right? Don't make mistakes like this 837 is being multiplied by the cos of C. So that means that the two of them glued together. You can't really minus or add anything to it. Yeah? So we dealt with this to get 900, right? We put the 900 and this on this side and the 441 on this side. We fling across the 900 to get minus 900 here, and we were left with the minus 800 here, right? So when we did that now, we saw that we ended up with minus 400 and something here, and then we carried the minus 800, the two negatives canceled, and that is what this ended up being, right? So let's try this one now. We have to find the angle C, which is this angle here.
Because we have two sides.
And the
two sides and the angle.
And the included angle. And it doesn't only have two sides, but it has all three sides. So I'm really happy about that. Could I use the sine rule for it though?
That's a little bit use the sine rule because it has all three sides.
Because I have all three sides. I have A, this is the angle A, so therefore this is the side A. Yeah?
Yes, sir.
And then I have this here is the side C, and this is the angle C. So I could use the sine rule as well. And let's do it both ways and see. Right? Let's do it both ways and see if we get the same answer. So the sine rule now, I have A and I have C. So I could say that A over sine A is equal to C over sine C. Right? I have A, which is 26, all over the sine of A, which is the sine of 103, and that is equal to C, which is 6, all over the sine of C, which is what I want to find. Right? So we have some cross multiplying there to do. So let's cross multiply that, and let's cross multiply that. So now I'll get the sine of C being multiplied by 26, and on this side I'll have the sine of 103 being multiplied by 6. Right? And what will I do? I'll just carry over the 26. So the sine of C is equal to the sine of 103 by 6 divided by 26. So what does this work out to be? The sine of C is the sine of 103 times 6 divided by 26. I got the sine of C is 0.2249, right, around that, right? So therefore C is the sine inverse of 0.2249. C gives us the sine inverse of that gives us 12.99, and it looks 12-ish. It definitely looks 12. Now let's see if we could have done this using the cosine rule. Right? So let me just take this. So let's use the cosine rule and see what's going on. We want to find the angle C. So that means that we need to use the cosine rule that has the angle C, the cos of C in it. Right? So the cos of C, the angle matches with the side we want to find, C squared, and we have that. And we have the other two sides too. We have everything we need. C squared is equal to the other two sides, A squared plus B squared minus 2AB, the other two sides, cos of C. So now I could make the cos of C the subject to the formula. Right? Let's plug in the values first and see. This is 6 squared is equal to A squared, which is 26 squared, plus B squared, which is 24 squared, minus 2 into 26 into 24 cos of C. Remember, this is all multiplied together, so you think about it like one unit. Yeah? Now let's just work out 6 6s are 36 is equal to 26 squared is 676 plus 24 squared is 576 minus 26 times 24 times 2 is 1248 times cos of C. Yeah? So now I'll just add this. So 36 is equal to 676 plus 576 is equal to 1252. I see something coming on here. 1252 minus 1248 cos of C. Right? So now I could throw across the 1252. Right? So because I only have these two terms, this one and this one, so I could throw across this one. Right? So let me write the minus 1248 cos C on this side, and that is equal to the positive 36, and then I'm minusing because I throw in this across there, so it'll become negative 1252. Right? So what is 1252? 36 minus 1252 is 1216. So I have here negative 1248 cos C is equal to negative 1216. So now I could take this and bring it across. So the cos of C is equal to negative 1216 divided by negative 1248, right? And that is, the negatives will cancel, of course. So 1216 divided by 1248 is 0.9. So the cos of C is 0.974. Did we get 0.9 last time? I don't think so. Right? So therefore, let me just check. Cos inverse. I wonder if I had. Oh, this one here was sine. That's why. The cos inverse of the answer is yes. So C now is equal to the cos inverse of that, 0.9, and C, we get the answer. I got 13.1 degrees. So this one here, using the sine rule, I got 12.99, and using the cos rule, I got 13.1. And at the end of the day, they're both pretty much similar, very, very, very similar, very similar, right? What do we want to find? We want to find the angle C, which is this, right? Yeah. So what do we have? Right? We have the side C, yes, and because we have the side C, right, we have the side A, and we have the angle A. So yes, we could definitely use the sine rule here. A over sine A, oops, no, I don't know what it is, equal to C over sine of C. Yeah, so sorry about this. I think my software glitchy a little bit because I use PowerPoint instead of Notepad, right? I'll try to remember that next time. So A is 29 all over the sine of A, so that is sine of 82 is equal to C, which is 20, all over the sine of C, which is what we want to find. So now we cross multiply. We can't just fling across. If it was on the numerator, we could have just fling it across. But so what do we have here? We have 29 times the sine of C is going to be equal to 20 times the sine of 82. So therefore the sine of C is equal to 20 sine 82 divided by 29, which is what? Somebody give me this. It's 0.683. So therefore C is the sine inverse of 0.683, which is 43 degrees, and it does look 43-ish. Yeah, 43 point something, 0.1. Okay. Nice. Bearings. And essentially what we're saying, what is bearings? Bearings is basically how ships navigate on the ocean. Right? They navigate with a bearing. And if you ever watch them military movies, they will tell you a bearing of 225 or a bearing of 045, you know? So what do they mean? When we're talking about bearings, we always talking about a north line, right? And we are always measuring the position of an object relative to another object is called a bearing, right? We always measure the position of an object from this point here. Like, let me just say this is the point A. Right? We're measuring the position of the object from this point on the north line. So let me just say I have a boat here, right? I have a boat, right? What is the position of this boat from here? Well, we draw a line to that boat and we say from the north line, we always measure clockwise. Is that clockwise? Yeah, that's clockwise. And we have an angle here. So the bearing of that boat is at a bearing of 45 degrees, right? If we had another boat, and let's just say, if we had another boat over here, and they say, well, what is the position of this boat from the port A? Well, we draw a line here, and remember this is the north line. We always measure a bearing north of the a bearing clockwise from the north line. So this boat here will be at a bearing, if we measure this angle here, it would be at a bearing of 225 degrees. Right? So remember, bearings are always measured from in a clockwise direction from the north line. Right? Everybody understands this about bearings?
Yes, sir.
Right? When we are referring to bearings, we always refer to it in 3 digits. So you wouldn't just say 45 degrees. If you're talking about 45 degrees, you're talking about an angle. You're talking about a triangle or a shape. You're not talking about a bearing. In bearings, we will say it is 0.45 degrees. Yeah? In bearings, it's like a military kind of thing. So we always include the 3 digits when we're thinking about bearings. Right? So 0.45, if something is dead north, then it is at a bearing of 000 degrees. If it is dead north. Yeah? So I hope that you guys understand. A ship travels from A. They just want to give it names and things, but a port, I guess, right? So a ship travels from the port A, and I'm not reading the whole question. I'm going and mark the port A, and look, they give me a north line there too. So okay, right? So a ship travels from the port A on a bearing of 30 degrees. So we could see here that it's traveling in this direction, and it is in a bearing of 30 degrees. Bearings are measured, just now, what the hell is going on here? Right. Bearings are measured from the north line. So that means that from this north line, this angle here is 30 degrees. And a ship travels from A on a bearing of 30 degrees, right, to B, and that is 90 kilometers. And this is why I hate CSEC. CSEC does weird questions, real dumb sometimes. It then travels to C, which is, you see, due east of A. So this here, right, I actually take this 310 to be this part in the sentence. But here, they're saying that C is 310 due east of A. Real dumb wording. And if they didn't ask the question, I would have still think it was this. So A to C, this here is 310 due east. So this is east, right? What you have to find is you have to find this over here. This distance between B and C. How are we going to do that? We have all of the information that they gave us. This here is 30 degrees. This here is 90. This side is 310. We want to find this side here. How are we going to do that?
90.
You minus the 30 from 90. That is very good, because remember we have north here and we have east here, and north to east is 90 degrees, and that is why they said here due east. Right? So if C is really due east, then that means that this here is 90 degrees. And if that is 90 degrees and this is 30, that means that this is going to be 60 degrees. Right? So now that we know that that is 60 degrees, what now? Now I would label. So I have, this is the angle A is 60, this is the side A, which is what I want to find, right? And I have the side B, this is the side B, and this is the side C. So I have all three sides, and I have the angle of the side that I want to find. So it should be easy enough from here. A squared is equal to B squared plus C squared minus 2BC cos A, right? A squared is equal to B squared, which is 310 squared, plus C squared, which is 90 squared, minus 2BC 90 times 310 by the cos of 260, right, which is the one inside the angle there, right? So A squared is equal to, calculator lady, 310 squared is, I'm just gonna add it one time, 310 squared plus 90 squared, and I got here, these two added together is 104,200 minus, and I'll just do this whole thing here, 2 times 90 times 310 is equal to 55,800 multiply by the cos of 60 is 27,900, right? So therefore A squared is equal to 104, my calculator lady is sticking, minus 27,900, and that is 76,300. So therefore A is the square root of 76,300. So A is, so the square root of the answer is 276.22. So 276.22. And remember, they go only have, in the formula sheet for the cosine rule, they go only have this. A squared is equal to B squared plus C squared minus 2BC cos A. So if it is that you wanted to find the side B, you have to be able to know, hey, B squared is equal to the other two sides minus 2AC. So you will have to know how to use it. Yeah, they're gonna have it there, but you have to know how to use it. So I have another question here. Let's just check it. From the diagram below, not drawn to scale, shows the positions of ports P, Q, and R. And they thankfully gave us everything in the diagram here. So we have ports P, Q, and R, and this is the north line here. Now remember, please remember, the north line goes through all of the points. Yeah, so all of the points you should consider the north line passing through it. They tell us here that this is 54 degrees, this is 80 kilometers, that is 100 kilometers. So let's see if they give us any more information. They say here that Q is 80 kilometers from P, R is 100 kilometers from Q on a bearing of 066. So they gave us that. So where should I put the 066? They say here that R, right, is 100 kilometers from Q on a bearing of 066. Where on the diagram does that 066 angle go? Caitlin.
It would be on the north line next to Q.
Next to Q, on the north line, in a clockwise direction. This is 066 degrees. Yeah? Because R, which is this point here, is 100 kilometers from Q, so from Q, right, on a bearing of 066 degrees. So we have the north line there. So they gave us that angle, and they didn't include it in the diagram because they wanted you to put it in the diagram. They wanted you to be able to identify where to put that angle, right? And of course, the angle PQR is 54 degrees, right? So calculate the bearing of P from Q. 2 marks. What's the bearing of P from Q? Of P. So P is at a bearing of what from Q? If this is Q, and this is P, and this is the north line, right? This here is the bearing of P from Q. So the bearing is measured from the north line to here, and you seeing what going on, Shazay?
Yes, sir.
So I don't need this. I just want this. And what is this angle, Shazay?
120 degrees.
How you get that?
Add the greater than.
You add 66. 66 and 54. So from north, this big angle here. From Q, the north line on Q, from the north line, that angle there was 66 and 54, 120, you said?
Yes, sir.
120 degrees is the bearing of P from Q. 120 degrees. So that entire angle there is 120 degrees, right? Caitlin, do you understand so far?
Yeah.
Soraya, do you understand so far?
Yeah.
Soraya, are you just saying here to make me shut up?
No, but you don't ask me to do anything.
Alright, okay, just making sure. Scotia, you understand how what's going on here?
Okay, so Daniel.
The cosine rule. We can see here that we obviously have two sides and the included angle. And this angle, the included angle, is the angle of the side that we want to find. So we want to find the side Q, because that is the angle Q, right? So if we want to find the side Q, Q squared is equal to the other two sides. So this is P, this side is P, because this is the angle P, and this is the angle R, so that means that this side is R, yeah? So Q squared is equal to the other two sides, so that is P squared plus R squared minus 2PR cos of that angle Q. Yeah, will you understand what I do here? Even though I change up the letters, you all understand what I did?
Yes, sir.
So say you're okay with this?
Yes, sir.
Alright, so now we could just find Q squared is equal to P squared. Well, 100, 100 squared plus R 80 squared minus 2 into 100 times 80, the cos of 54. Alright, 54 is this angle here. Right? So Q squared is equal to 100 squared, which is, I'll just add it all up, 100 squared plus 80 squared gives me 16,400 minus 200 times 80, 16,000 times the cos of 54 is equal to some big number there, 9404.56, right? And I'm not going to just use this one in my calculator. I'm actually going to use the long decimal from my calculator. So I'll do 16,400 minus the answer, right? And that gives me Q squared is 6995.44, right? And therefore Q is the square root of 6995.44, which is square root of the answer equals 83.63. this is 83. I don't know. You think? Well, they say it not drawn to scale, right? Because it looks a lot longer. If this is 80, this looks a lot longer than 80. Yeah. But they say it's not drawn to scale, so maybe it is 83.63 thing, right? So we got that PR, right? So PR is 83.63. That was 3 marks. You would get 1 mark for the formula, 1 mark for the answer, 1 mark for the working, and that is where your 3 marks would have come from. The third question, the measure of the angle QPR. So the angle QPR, just let me make this smaller so I can decide here. Right. Oh, where did you go? Where do you go? Okay, there we go. Right. So the angle QPR is this angle over here. How am I going to find this angle over there? What should I use? Okay, I could use the cosine rule, yeah, but the sine rule would be a lot better, right? Because I have a side and its angle, and then I have another side and its angle. Yeah, so I could use that, right? So imagine Q over the sine of Q, that is the side and its opposite angle, right, is equal to P all over the sine of P. And sine of P, this one here is the one we want to find. Yeah, so you can see here that this makes it a little bit easier. Q is 83.63 all over the sine of Q. Well, we have the angle Q here, the sine of 54, and that is equal to P, which is 100 all over the sine of P, which is what we want to find. So we will do a cross multiply. So that means that 83.63 times the sine of P is equal to 100 times the sine of 54. Okay. So now I could say that the sine of P is equal to 100 sine 54 divided by 83.63. So 100 times the sine of 54 divided by 83.63 is equal to 0.967. And therefore P is going to be equal to the sine inverse of that, which is sine inverse 75.3 degrees. Yeah. So you can see trig 2 is where we were working with our sine rule and cosine rules, and I've put these 3 bearings questions, all of the bearings questions on the end. I'm actually going to move them more to the middle. So all of these are CSEC questions, right? So the bearings section, right after sine and cosine rules. So these are the 8 questions we did for sine and cosine rules, and then they had the link for more, right? You're seeing this, right?
Yes,
Right, and now we have here the bearings questions. We have 1, 2. Well, we already did this one, right? And well, this isn't a bearings question, but it is relevant, right? So you could do for homework, you guys will do these questions on bearings underneath bearings here. 3, 4, 5, 6. So well, not 5, 6. This is 5 here. So it's just 5 bearings questions we have there. Nice. Everybody cool?
yes, sir.
All right. Now, lastly, but not least, is this. All right. We are talking about the area of a triangle. Now, at the end of the day, I've never really seen this brought as a question in CSEC. Like, I can't really even go and find any CSEC questions to give you on this. Yeah? I haven't actually ever seen it in a CSEC question. Right? I do believe, I can't remember if it's in the formula sheet or not. And no sine and cosine rules are in the formula sheet. I can't remember if this one is. However, it is on the syllabus. It is in the curriculum. So you do have to know it just in case, right? And this is the area of a triangle. Now at the end of the day, all of the time you've been doing the area of a triangle, you have always needed the perpendicular height. Now if it was a right angle triangle, well then your life easy. Your life easy because you'd already have the perpendicular height. But if it's not a right angle triangle, then you're going to be praying that they give you that perpendicular height. Because if they didn't give you the perpendicular height, you would have ended up in trouble. Yeah, you might have had to probably go through all kind of Pythagoras and thing just to find the perpendicular height before you could even tackle the area. Right? But now we're dealing with an equation here for the area of a triangle that you do not need the perpendicular height for. Yeah? So you don't need the perpendicular height for this. At the end of the day, it's still just all about knowing which sides you have. So if you look at it here, a half AC. AC is these two sides, right? The sine of the angle between those two sides, which is the angle B, opposite the side B. So, just like the cosine rule, if you have two sides and the included angle, then you will be able to find the area of the triangle using this formula. Right? Two sides and the included angle. Right? So, we have an example here where we wanted to find the area of this, and you can see here that we have two sides and we have the included angle. So we just use this area formula, a half the two sides, right, 8 and 10, by the sine of the included angle. And that will give us that. So this one is pretty easy for you guys, right? How do you feel about this? Simple?
Okay.
Yeah? Okay, alright. So let me get this one. What is the, try this one. And I'll want to hear this one from Caitlin and Soraya actually, right? So Caitlin and Soraya, you guys will try to answer this one. And we will see if you can't answer it, we will see if Shazia and Scotia can help you out. So the first thing is, I know that the area of a triangle is a half the two sides by the sine of the included angle. Is that the first thing you have?
Yeah.
Right? And they actually give us the area 310. Right? So therefore this side is 310, the area of the triangle. And that is equal to a half of the two sides, 29 and 25. 29 times 25 multiplied by the sine of the included angle, which is the angle we want to find. Do you have that?
Yeah.
Alright, so we look like we're going good there so far. 29 times 25 is equal to that divided by 2 is equal to that. So 310 is equal to 362.5 sine x. Did you get that?
Yep.
So 362.5, I fling it across. So I'll get sine x is equal to 310 divided by 362.5. You agree with that?
Yeah.
Now what you get for the answer?
0.855.
0.855.
Yeah.
So therefore x is the sine inverse of 0.855, which is
58.7.
very good. Soraya, how you feel about this one?
Can you understand what she did?
Did you do this?
No, I didn't get that.
All right, yes, all right. So that's okay, that's fine, because you, as I say, I'll let you off the hook. This is Form 5 stuff, but it's really just a simple formula, and it's about knowing what to look for if you have the formula, right? So just to recap, right? For the sine rule, all right, no, let me start with the cosine rule. The cosine rule, you're looking for two sides and the included angle. That's a hint. For the area, you're looking for two sides and the included angle. That is a hint. But for the sine rule, what you're looking for is a pair of side and angle, and then side and the corresponding angle. All right, once you have a pair of side and angle, all right, then you could use your sine rule to figure out one of them, whether it's a side or an angle, right? So that is it for trigonometry, actually. And you can see here that we also have some of the area questions here. So I'd like you to do these 4 area questions for homework, right? And it also have links here for everything that we did. So all of these links here for sine and cosine rule and for area as well. All right. So for homework, you have the 5 bearing questions to do. You also have these 4 area questions to do, and right. All right. Well, here what we'll do this one, and then we will do these 3 for the next class, just to finish off trigonometry, and that'll be it for trigonometry. And have a couple of little things I had to show you guys in trigonometry again, right? And I'll leave you all with a little piece of homework with those little things, right? So write down this homework actually before I forget, right? For next class, write down what is a radian. Yeah, just answer this question for me. What is a radian? And something else I had there. Yeah. Right. So what is a radian? See if you can answer that question for me. All right, for next class. Radian is not something that will come in the exam. You don't have to worry too much about it, but it is on the syllabus in terms of knowing what it is, right? So, oh, where's the next one? Okay, yeah, don't worry. All right, yeah, don't worry. I will know what it is. Right, so I'll show you. So let's take a look at this. Now, Shazay, you said you did this one, right? And so
Yes,
did Scotia, right? So the center A, a circle center O with radius 6 centimeters. So we see in here that each one of these lines that's spreading out from O to the circumference will be 6 centimeters. 6, 6, 6, 6, 6, right? Is inscribed inside of triangle ABC. So you can see ABC. We can see here the circle inscribed inside of ABC, right? The sides of the circle touch the triangle at those points X, Y, Z, right? So this is where, and even though it doesn't look like it because it's not drawn to scale, but this is where the circle just touches, you know? So each side only touches the circle at that one point, and therefore each side is a tangent. Yeah. Find the lengths of the sides of the triangle. Triangles. I guess they mean the big triangle ABC, right? So find the length of the sides of the triangle ABC. Is that what you did, Shizek?
So I find the lengths of all the lines
All-
besides the radii. Yes.
So you have the length of the triangle ABC.
Yeah.
All right. So how did you do it, right? Like let us know.
I just use the, well, for like the bottom, it was 66 degrees.
This is
Because,
60.
Because of the, I'm not sure which theorem it is, but the theorem when you say two things.
Two things, child.
Hold on.
you had to know them theorems by heart. All of them.
Yeah.
All of them. I'm not
Yeah.
talking about circle theory. I'm talking about all of them. You had to know them by heart, right? Now, first
Yeah,
thing I
because-
noticed is that it have a big triangle here. This is 66.
Uh-huh.
This is 54. So that means I could find this angle here. Yeah.
Yes, sir.
So what our angle is? Did you work that out? 180 minus 66 plus 54. Is this 60 degrees?
That's 60 degrees.
66 plus 54 is 120, and 120 is minus 180 minus 120 is 60 degrees. All right, so that is 60 degrees there. I know that these angles here are 90 degrees because of the theorem. Oh, by the way, the theorem to get 60 degrees, you could just quote angles inside a triangle equal 180. That is the theorem for that, right? All of these here are 90 degrees because a tangent will touch a radius of a circle at 90 degrees. That is the theorem for that.
So
Yes.
I did this question before I was before we talk about the whole adding up all the angles to make it 180. So yeah, I did this whole question wrong because I put 54 and I put
You put what?
I put 54 and I put a and I said the question wrong.
You put 54 over here.
Yeah.
Alright, because you assumed that it was an equilateral triangle.
Yes.
Alright. Well, let's just see. Because actually, you might not be that wrong. This distance is equal to this distance. Right? And that's one of the theorems. Right? Which means, and so we could actually have that there. One of the theorems being that this distance is equal to this. Then we have this distance being equal to this distance over here. That is the same theorem, of course. Right? Once you have two tangents meeting at a point from where they touch the circle, right, they will be equal. So this is equal to this, right? And then this here will be equal to this. And that is this distance and this distance. So we do have some equilateral triangles taking place, right? We do have some equilateral triangles taking place, yeah? And if this is an equilateral triangle, right? We could see here we have two equilateral triangles. We have this bigger one over here. That is one equilateral triangle. And then we have this smaller one over here, which is made of the radius, because these two radius, not equilateral, isosceles, sorry. So these two radius are the same. In fact, all of the radius are the same. So we have numerous equilateral triangles. Look, we have an equilateral triangle here. Well, I keep saying equilateral, it's actually isosceles, right? So because we have these two being equal, and these two being equal, and this line coming down the center means that this line is bisecting, right? It's bisecting this triangle, isosceles triangle. And if it's bisecting the isosceles triangle, that means it's bisecting this angle, which means that this will be 33 and this will be 33 to give you the 66, right? Same here, this line will be bisecting this angle, which means that what's 54 divided by 2? It's 27. So I have 27 here and 27 here, right? That means that this is going to be 30 here and this is going to be 30 here. Right? So now we have some angles in place there. Right? This side is 6. Right? And now let's see if we could find something, right? If this side is 33 and this side is 90, right? Look, this is 90 degrees here. This is 33 degrees here. Yeah? Can I find, this is 6 over here. Can I find the length of this entire long side? How would I do that? Scotia, yeah, saying no. And what about the length of this side here? Can I find that? This is a 90-degree triangle. This is a 90-degree triangle, right? I know 33 and this is 90. So if this is 33 and this is 90, that means I could find this angle. Yeah. Scotia, any thoughts? Are you lost?
I'm not lost.
Right. How did you approach this question?
Well, for that question, I think it says to find the sides of all the triangles, so I just found all the small triangles, maybe the triangle, the big one.
Right.
I didn't find the big one.
And I really think that it's supposed to be a, sorry if this was written wrongly. Find the lengths of the sides of the triangles. That is a crazy question, right? But you could see here, how could we find, you know, we could find this angle here, 90 plus 33. 90 plus 33. This is 123, right? So 123, 180 minus 123 is equal to 57. So this is 57 over here. And since this is 90 and this is 33 over here, means that this here also gonna be 57. Yeah. So this is 90 and this is 30. So that means that this angle over here is not gonna be 57. It's going to be 90 plus 30 is 120. So 180 minus 120 is 60. This is gonna be 60. And if this is 60, that means this gonna be 60, right? Because this is 30 and this here is 90. So for this triangle here, this will be 60. And if this is 27 and this is 90, well then 90 plus 27 is equal to 117. 180 minus 117 is 63. That means that this is 63 and this is 63. Now let me just see if that is true, right? 63 plus 63 plus 57 plus 57 plus 60 plus 60 equals 360. It's true because I added all this 60, 60, 63, 63, 57, 57. I added them all up and I got 360 degrees, which means that my reasoning is true. Yeah? So now, it's just a matter of doing the same thing for all the triangles, because if you look at it here, for each triangle, I have one side, right? This side is 6 for this triangle here. So for each triangle, I have one side, right? And I have all of the angles inside. So can I find the other two sides? How? How do I find this side over here? What should I use? Look at the angle here. And with this angle, this is the adjacent, this is the hypotenuse, this is the opposite. Right? I have the opposite. I have the adjacent. Opposite over adjacent is tan. So I could use the tan of 30 is equal to opposite, which is 6 over the adjacent. From this, I could find the side A. Yeah? And then I could also do the same thing with hypotenuse. Opposite over hypotenuse is sine. So the sine of 30 degrees is opposite over hypotenuse. So from this, I could find the side H. Yeah. So once you have all of the angles and you have that one side, you could use sine, cos, and tan to find the lengths of all of these sides here. Now, I promise you, you'll never get something like this in CSEC. I promise you that. Yeah? But how do you feel about this question? Shazia and Scotia.
I feel better about it, but it would have been nice if it was worded differently because I didn't really do that.
Right. What did
It
what,
wasn't bad.
you well I mean, yeah, it would have been nice, but at the end of the day, I just showed you how to find the lengths of the sides for all of the triangles. Huh? Yeah. Now at the end of the day, if you found this side, guess what? This side is equal to this side. Yeah. So therefore, these two triangles would have been done. Yeah. If you find this side is equal to this side. So you know these two triangles would have been done. Yeah. And so you could definitely find all of these sides. Shazay, how you feel? Well, it's almost 8 o'clock and I'm sure you guys are tired, right? So here what? Next class, we will go over this question one more time and we will tackle these three. So make sure that you could try and do them if you did not do them before.